Hello, welcome. I'm Stgy Sandhya, Assistant Professor, CSC Department, Gokraju Rangaraju Institute of Engineering and Technology. As a part of the course Programming for Problem Solving, today in this video lecture, we are going to look at searching and especially linear search. Okay, so what is searching? Searching is a technique of finding an element in a list of elements or in a data, in a given data. So it's a technique to find out an element either from a sorted list or from an unsorted list. There are two types of searching that you are going to look at as a part of the syllabus: linear search and binary search. So let us proceed and look at what is linear search. So linear search is also known as sequential search. Linear search is a method of searching in which every element in the list is compared to the element that needs to be searched for. So if suppose I'm searching for an element called X, X is then compared with all the elements of the array or the list starting from the first element till the last element. At any point of time, if the element is found, the index of the element is given. Otherwise, at the end of the process, once when the end of the list is reached, it returns -1. So what are the advantages of this sequential or linear search and its demerits? The advantages include a simple method. It is usually preferred when the elements are at the start, and it also does not bother about the ordering of the array. These are the merits of this sequential search, whereas it has got its own set of disadvantages as well. They include it consumes more time and it takes a lot of computational resources when the list is pretty large. This also requires, whenever the elements are very large and clearly it's not predictable to determine where the elements are, it takes more time. What's the complexity of linear search? We will analyze this in a deeper concept later on videos, but now the best case complexity is O of 1, the worst case is O of n, and the space complexity is O of 1. Okay, now let's just check once an algorithm for linear search and then try to fix out what this is. So how does the algorithm look? The algorithm can be simply explained like there are multiple ways of people writing algorithms. This is one, this is the other, and this is the other. Okay, let's just, for example, consider this algorithm. And what does it say? So set your I to 0 and go till n-1. What is n-1? You have a linear search works on an array A of n elements. You're searching for the item, and if you found its position, you will put it in the location. Location is generally the expected position where you put your algorithm. Item is the element that you're searching for. N is the number of elements in the list A. Okay, so from 0 to n-1, since array indexing starts with 0, you proceed from the first element 0 to last element n-1. If at any a of I, if you found that it is matching with the item that you are searching for, you will simply update the location to I and you will exit or stop the process or return simply. But otherwise, at the end, whenever you reach the end of the list, n-1 is reached and you did not find your element which is matching to item, we will return -1. So this is the code. When we say -1 implies that the element is not found, and when we give some I implies that the element is found. Okay, so this is what it means. Now, how does linear search generally gets executed? Following are the steps that needs to be followed while we are working with linear search. Traverse the array using a for loop. For every iteration, compare the target value with the current value of the array. If the value matches, return the current index. Otherwise, if it does not match, move ahead by incrementing the loop variable and check with the next element. And finally, if no match is found, then simply return -1. So this is a simple program for linear search. This is where here you read your array and then you try to read the element that you're searching for, which is nothing but k. So here you are passing your array and an element k to be searched. So if any a of I is equal to k, you will return the index I, implies a successful search. And if you return -1, implies that the search is unsuccessful. So here is a sample example. When you know that your n value is 6 and your elements are this, you're searching for 55. 55 is not there. 55. Okay, sorry, it's a printing mistake. It's not 55, it's 5. 5 is the element that 15. 15, sorry, 15 is the element that you're looking for, and 15 is not there in the list. So therefore you say it's unsuccessful search. And at this point of time, you're searching here for 55. 55 is present in the list at 0, 1, 2, 3, and 4. So therefore you return the position 4, stating that it is a successful search. For example, let us consider this example. So I'm searching for 3. So therefore, is 10 equal to 3? No, move ahead. Is 7 equal to 3? No, move ahead. Compare with the next element. Is 1 equal to 3? No, move ahead. Compare with the next element. Is 3 equal to 3? Yes. So therefore, we say that, we found the value at the position 0, 1, 2, and 3. So we say that the element is found at 3. So let's just understand with this graphical example for a successful search case of a linear search. So there are 5 elements in this array, 20, 10, 30, 25, 17, and 5. Clearly stated, they are all the unsorted elements. Okay, so what we are going to search is 17. So now set I to 0, compare the element at A of 0. A of 0 is having 10, so 10 is equal to 7. No, so therefore increment I, proceed, make the element that you are searching for is, sorry, the element that you're searching for is 17. It's not 7. There's a small mistake here. 17 is equal to 30. No, so therefore proceed, make I 2. 17 is equal to 25. No, so move ahead. 17 is equal to 17. Yes. There's a mistake here. S. So therefore you return your element. It's S. So therefore you return the index I is equal to 3, stating that it is a successful search. Let's take the same example for unsuccessful search. I'm searching for 7. 7 is not equal to 10. No. So set I 1. 7 is equal to 30. No. Make I 2. 7 is equal to 25. No. Make I 3. 7 is equal to 17. No. Make I 4. 7 is equal to 5. No. So increment I. I now becomes 5. But at 5, that implies that you have reached the end of the list. Since you have reached the end of the list, you got to just say that the element is not found and the search is unsuccessful. So before I close, I recommend all of you to take a pen and a paper. And because I've shown you number of algorithms, number of ways of writing algorithms, you design an algorithm and a flowchart for yourself for linear search, and also try to analyze the linear search this way as shown. You got to show the successful and unsuccessful search this way using the list 10, 7, 2, 8, -5, 3, 1, 6 to search for the values 9 and 3. Also analyze the merits and demerits of linear search to proceed. Okay. So that's it. Thank you.